This morning we have the honor for a guest lecturer from Professor Stephen Cairns. He is the director of the Future Cities Laboratory. Maybe Professor Cairns will explain a little bit more about that. It's located in Singapore and is under the ETH, in Zurich, the house school. Today topic is the ur-scape. It's application that is also used by the municipality environment. So we as urban designers may as well learn how to operate and what's the concept and so forth, so that we can also interact with the ur-scape. So without further ado, please have your session.
Can I just speak like this? Is that all right?
Yeah.
Yeah, it's all right. So thanks, Mario. It's really nice to be here again. I love coming here because it's a famous campus, famous architect, and also a famous program. So, and also we're close, so we're neighbors. So I'd like to talk to you a little bit more about what we're doing. This is ur-scape software. There are two places now in the world where it's most developed. One is in Singapore, where we developed it, and the second one now is Bundle, because the Bapeda team here have adopted it and are starting to use it, so we're very excited about that. I'll tell you more about that as we go along. So the format is, I'll tell you a little bit more about the research background and maybe some of the experiments that we did to get to this point. And then Rosita will talk to you, give you some scenarios about how it works, how it functions, some demonstrations. But just a little bit of background. This is us, Future Cities Laboratory. We're based in Singapore. We're fairly permanent, so if you're in Singapore, come and visit us. We're on the NUS campus. We have an open door policy, so please come and visit. You can see work that we're doing, but there are many other colleagues working on different aspects of future cities. Sometimes Singapore focused, but also sometimes offshore. So I'll talk a little bit about this software ur-scape, but I will begin by telling you a little bit about urban and rural systems, and I'll really think about this as a kind of urban design, why urban designers have to be thinking about agriculture and the rural condition, and why that's especially important in Indonesia. So this is the kind of main argument. So let's start thinking about the rural. I know that we're all urbanists, but why do we have to start thinking about the countryside? And I'll start with that argument, and then we come to ur-scape, which was designed as a tool that tries to think about the countryside and the city at the same time. So ur stands for your or our, but it also stands for urban rural. So inside it is the concept, and I'll tell you about the concept before we come to the software. So let's dive in. This is a kind of a 101 agricultural science for people who've never done agricultural science before, people like me. So 4 or 5 years ago when we began this project, we came across this statistic, which is quite amazing. There are 50,000 plants in the world, edible plants in the world. Just 3 of them provide 60% of the calories for the whole human population. And those 3 are rice, maize, and wheat. So it's quite an amazing, I think it's a very delicate issue about how we think about food, particularly as cities and food-growing regions start to intersect. So I think this becomes a really big emerging part of urban studies. It's not just urban but countryside issues. So we started with this fact, and we started to kind of develop and start to think about this quite amazing non-urban fact. Maybe you've seen this map already. This is from 2007, and this is a really important map because it announced the global tipping point between urban populations and rural populations. Historically, for all of human history, populations were mostly rural, and it was only recently that those populations started to move to the city in the 19th century, industrialization in Europe, and then the global tipping point was reached in 2007. What this map shows, of course, is that global tipping point is still very uneven. Basically, Europe and North America is at 80% urbanized. Asia, including India and China, is still rapidly urbanizing. So inside that very large media story are some much more interesting facts about why we have to think about the rural. It's our responsibility in this part of the world to think about the rural, because in the West, the rural is already a kind of historical phenomenon. So this is a really important framing topic. This is another diagram, basically, of the same data. The UN puts out these drawings every 2 years in their their urban prospects book. So the red line, there's two clusters. The green and the red line is basically Asia and Africa, and the two bottom lines are basically North America and Europe. And it's showing urban and rural populations, and they're intersecting. So what's important about this? Actually, I've got this contour. So these two lines intersected over here somewhere before the war. So that means Europe is already highly urbanized, and the rural populations are very, very low. In the case of Asia and Africa, you can see this is the urban population, this is the rural population, and in another 2 years, they will reach this tipping point, and then they will start to diverge. So this is an amazing phenomenon that we're living in right now. It's very, very fast urbanization, and then very soon this will be a very steep depopulation of the rural areas. So what we're interested in is what happens here. These people, of course, are on very minimal wage. It's not very profitable to grow rice. But the people who are growing rice are feeding the people in the city. So what happens when the urbanites increase in number and the people producing the food decrease in number? So what happens with this gap? And of course, this has to be an urban question for this study. And again, I just emphasize this point. This is a responsibility for Asian theory and practice, because Europe has already undertaken that transformation a long time ago. So how is that gap filled? At the moment, that gap is filled by the increase in the yields of those three crops. So this is the increase in yield over time, so millions of tons. So rice continues to improve, so does wheat, and so does corn. And that's because of new agricultural practices, improvement in seed technology, and improvement in genetically modified crops and so on. But that can't go forever. You can see that these improvements are already unstable. So we can't rely on agricultural science or agricultural practice to continue to become more and more efficient to feed these larger and larger numbers of urban residents. So let's put them all together. This is the big urbanization story. This is the kind of urban-rural diagram. This is the kind of rise in food productivity, which is filling that gap at the moment. This drawing simply shows that these are world urban population predictions. This is the current prediction of about 9 billion by the end of the century. Last year they said actually maybe that's an underestimation, and that figure could be 10, 11, 12 billion. So we're still massively underestimating the number of people who are growing on the planet. And furthermore, all of those will be urban residents. There'll be no more addition to the countryside. That countryside population is moving to the city. So this is also massively significant for this kind of larger question. And then finally, this one is very interesting. This is the current footprint of cities, the total footprint of built form in the world, and it's increasing by about 1% per annum. So in other words, we are all individually taking more space as we urbanize. So Singapore tries very hard to think about density, but it's the unusual case. Mostly people are using more and more space. If you add that all together, then there's a more than double, maybe almost triple by 2050 of the total population getting wealthier, becoming more urban, and taking more space per person. So that means the cities are simply growing larger. There's nothing we can do about it because the phenomena are so sort of macro. And this is to do with our own individual wealth, our own desire to have more space. It's to do with fragmentation of family sizes, smaller families, and so on. So there's many, many, many factors inside that. But this is the kind of overarching framework for why we in Asia have to think about the rural relationship inside the urbanization story. Okay, so what we did then is I'll show you that same information in a spatial form. So that's our background. So we're architects and planners, and we're starting to think about agriculture. So that's basically common knowledge. For some reason, so we took that same information, the same data, and we spread it we spatialized it. So this is wheat distributed around the world. This is maize. Maybe you know this story already. You can probably imagine where rice is going to So look how concentrated rice is. It's really 99% is in Asia, and then 99% of that population is also coinciding with a lot of that rice growing region. So let's look at that overarching framework in a bit more detail, and this starts to help us think about the form of cities and the relationship of cities to agricultural regions. So in North America, this is the distribution of wheat, and then in a very beautiful jigsaw way, maize, and there is some rice, especially in California, in the Midwest, and then other crops, of course. Now look what happens, the red in a minute, you will start to see population densities. Now what's really interesting about those is they're emerging in between the agricultural territories. And these are very large conurbations, but they don't overlap very much with the rural regions. And you'll see the same pattern in Europe. So keep a lookout. In the agricultural pattern, look where Paris is and London is and Berlin. You'll see them as holes inside the rural fabric. So it's wheat. So you can see where London will appear and then Paris in a moment. So the red is population density. Yeah? So you look when we overlap that data. So here the relationship between cities and countryside is very clear and crisp. You're either in the city or the countryside. There are suburban spaces, of course, but it's unusual, which is why there's no real story of theory of sort of Desakota, for example, coming out of Europe. Now let's look at the monsoon Asian region that we were talking about earlier. Of course, this is still very productive in terms of wheat in the north. Maize is very significant. But look at the rice, the dominance of rice. Java, all of that Bengal area, all the major watersheds, the Champraya River, the Mekong, and then this is the population density on top of that. Now you notice here there's a lot of overlap between productive regions and high density. And then when you add them all up, these are gigantic, really gigantic concentrations of people, much larger than, say, the Boswash area or the Rhine-Ruhr area in Europe. So this is a massive, massive challenge for all of us thinking about cities in this part of the world. Okay, now let's turn a little bit more to Indonesia and areas that we're familiar with. Does anybody know what this image is? Huh? Anybody recognize it? It's easy enough, right? This is Surabaya and Bali. So it's basically eastern Indonesia. Nightlife data from NASA. I love this image because it gives you a different image of what the city is, right? I mean, Surabaya is like a city with a boundary. But look at the way Surabaya and Malang are kind of almost continuous, right? And then what I also love is this. These are obviously city centers. We recognize these as cities. But what's this here? This is very, very densely populated rural areas. And it's only you get that in Java and you get that in the Ganges watershed, and you get it around the Mekong, around Kanto, in that area. So it's a very unique phenomenon. And light is a very useful proxy for wealth. So there's a very interesting discussion about nightlight data for those of you working in planning and geography, for example, thinking about the relationship between nightlight. So light is often a proxy for a move from a rural economy into a kind of mixed economy. So if you're living here, you're probably not just for farming rice. You're probably also, maybe your children are doing an MBA at the university, maybe you run a business at the same time. So the landscape is transforming in a very interesting way. But it's not always about Surabaya and Malang and Jakarta and Semarang. It's about this other space in between. So here's another image of Java, and you may have seen this one before. But it's almost as if the whole of Java is kind of urbanizing. The only places which are not urbanizing are the volcanoes. Just simply because you can't occupy them. It's a dangerous thing to do. So this is a really important image, and it's completely different to Europe and America, where those concentrations of light are much more tighter. And that's simply because the population densities in Europe and America in the countryside is very, very low, because these are basically mechanized. They're mechanized robotic Okay, let's back up a little bit. I'll just tell you a little bit of the theory. I think maybe some of you know this already. I won't spend too long on this. This is a very old book, very beautiful one on the concept of monsoon Asia. So it's no accident that rice grows in Asia because it's exactly where most of the rain falls. So there's a climatic relationship between where rice grows and where the rain falls. But rice brings other things. Rice, as opposed to maize and wheat, is very, very labor intensive. So you have to have people in the countryside looking after the rice and growing the rice. So if you have lots of water, you have lots of rice, it's tropical, you always have lots of population. So this is a really important parameter. It's also a reservoir of labor, it's also a reservoir of water. It's not soil dependent necessarily, so rice grows very shallow and it gets its nutrients from the water, not from the soil. So this is a very important parameter that makes it different from maize production, for example, or wheat production. Is relatively high yields, but it's very resistant to mechanization. So you can't just drive a tractor across a rice field, because of course it will sink. And so it's a very complicated process. So if you want to liberate all of this labor, you don't want to have the whole population endlessly laboring in rice. If they want to have aspirations, then mechanization has to come in to support the continued yield of that landscape. So it's a very complicated relationship. At the moment, Java has very high manual labor, there's very little mechanization. Compare that to Japan, has very high mechanization and very high productivity of rice and relatively low populations in the countryside. And I'll show you a little bit more about that in a minute. So there's also a problem that somehow this combination of labor, water, and yield, high yield but low cost. So a typical farmer, does anybody know? I'd be interested to know. What does 1 hectare of rice produce in dollars? I didn't know this either until a couple of years ago. Any guesses? 1 hectare of rice, what's and one crop? Can you have a guess? How much in US dollars? Huh? Just guess, just let me. No, it's about 500 if you're in a good, in a well irrigated area. So one hectare, which is a typical size of a farm in Java, produces about $500 US per crop. So let's say that farmer can do 3 crops a year, which is, you can do that in Java, but not many other places. That's $1,500 US for a family of 3 or 4, 5, 6. So it's not much fun, and it's very, very hard work. So it's no wonder people want their children to do MBAs and start to move away from rice. But who's going to produce the rice that we all need to eat, right? So this is this UN chart. So there's a lot of discussion in the theoretical literature about the idea of a kind of enslavery, that you lock the large body population into low-income, hard work for low returns, which we all need. So it's a very complicated set of scenarios. So this environmental envelope is very important, because I think we have to take that kind of macro idea. And then of course more recently, this is a much older book, but more recently One Belt, One Road. There's a whole range of different infrastructure projects which are starting to think about how you activate that kind of landscape. And of course, if you're an overseas foreign direct investor, you're looking at this labor. You say, now that's very cheap labor. And if I inject the right amount of capital, I can turn these into factory workers and I can start to extract wealth and product from that relationship. So it's a very, very complicated political economy going on here as well. So that's one aspect. And then our approach was to say, well, how do we start to study that in more detail? We need more data and more understanding of how that landscape works. First of all, if you're working in remote sensing or GIS, you know that there's incredible techniques now coming out from satellite imagery. This looks like a Google Earth image, which is useful, but if you get multispectral satellite data, you can delaminate that data and you can start to allocate different land uses, far, far more powerful than Google Earth. And that allows you, in a way, a kind of X-ray view of the landscape. And here's an X-ray view. This is a region around just west of Jakarta, west of Jakarta. And here you can start to delaminate each of these and say this is kind of hard settlement, but this is kind of in between kampong desa. And you can start to see the different configurations of that kind of landscape as well. And you can also start to see how it intersects with agricultural regions. which is what we saw in that NASA image. So the NASA image is useful, but this is much more scientific because we start to understand what is the configuration and the morphology of that landscape. And then we designed, well, of course we can't do all of this. We don't have too much money in our project, so we can't buy very expensive satellite data. For those of you who know, it's incredibly expensive. So we decided to identify a number of sites where we could start to study on the ground. So we combine the satellite data with interviews, so we understand the everyday practice as well. So we're guided by the satellite, this kind of ethnography. So we work very in a lot of detail with stakeholders, communities, but also government departments and so on. So here's what you start to see. This is the same part of Surabaya, that condition we were looking at. But here it changes the color according to the data that the camera sees, which is on the satellite. And that's also a very powerful way of starting to kind of disconnect and start to analyze these sorts of conditions. So here's that same kind of image, but this time not using light, but using multispectrals. And then we assemble that. We have 5 different sites. This one's Calcutta. This one is Dhaka, Jakarta, Chengdu, and Shanghai. So these are different sites all around Monsoon Asia. As I said, you can't do the whole thing. At least we can't do the whole thing from satellite. So let's take some case studies, and then we build up higher resolution information about each of those sites to understand it in more detail. And then you can start to do these transformation studies and see how they change according to different land uses and so on. And then this is the work of my colleague Chen Ting, who's working. This is up here. And this is, we can start to study the way the Chinese state is trying to compact that fragmented landscape. So in Java there's a different policy, but in China the government says we can't have fragmented landscapes, we have to compress it. And they do it in a very top-down way. So this is the current condition, and this is the plan. And they do that because they want to industrialize the landscape. And you can't industrialize 1 hectare at a time, you have to have 20 hectares together. So people have to release the land, they have to concentrate, and that enables higher productivity and lower densities. Okay, you with me so far? That's the kind of argument, why we have to do it, and then we start to think about methodologies about how we do it as a group. Then we started thinking, this is where the ur-scape story starts to happen. We said, well, there must be a way of understanding that same data in a slightly more intuitive way, because we can't take the edge of DKI or the edge of Bandung as it's a political boundary, but it's not an analytically significant boundary. Population extends far beyond that. So we have to look at the data, not the political data, but the kind of raw demographic data. So we started doing this. This is a very simple early version. You'll see in a minute, Rosita will show you the current version of the software, but this is alpha, very early. But what we can do is we can look at a combination of these data sets. So this is population, and this is the 3 crops, maize, wheat, and rice. And we can combine them. The very first thing that the FAO says is about this kind of this relationship. So we can combine them and start to see the relationships. So what this map is showing is population density here in white at 700 people per square kilometre. Now 700 people per square kilometre is quite low for a city at least. But if you go to Atlanta, Georgia, that's a city about 5 million people. You go to Jacksonville, Florida, 1.2 million. That's the average density for those cities. So you can see across 1,000 kilometers of Java, there is already something like an American suburban density already appearing across the whole of that region. If we go further up, let's say 1,000 people per square kilometre, so the Gold Coast in Queensland, Brisbane in Queensland, these are large cities by Australian standards, and you can see this is a very large extended archipelago of density. These are not cities, but densities that are city-like. And don't forget, this is 80 million people inside that. So this is not a city any longer, it's some other very large extended combination. And we can also start to study, let's go further up, 50 million. Let's imagine a city of 50 million in Java. Then it would be like Bordeaux in France or Edmonton in Canada. And these are all tiny in comparison. So there's a radically other kind of condition emerging, and you have to have the tools and the data to just think about how you analyze that. And then finally there's a city about 40 million, which is about the same density as Chicago. So this is a seriously striking phenomenon. So to do that, we couldn't rely only on satellite data. There is satellite data here, but we had to bring population density data on top of agricultural data. And that's the first time we think that when we started to understand the relationship between us as urbanists and understand the relationship to agricultural data. And that's why it becomes kind of very interesting, I think, for this kind of wider disciplinary discussion. And here you can see underneath is very interesting. You can take a section through here. And this section is showing you population density in red. It's showing you, I think this is maize and this is rice. But they're almost at the same point. So this is a really, again, unusual condition. And then we started to take that data and we made a kind of a simple sort of tool. I don't know if I'm going to have time to show you. I'll just show you how this kind of works. So let's go if I can show you live. We took all those parameters and then tried to make a little sketch. So this is the same drawing, and what it shows you is population density in red, and then agricultural productivity in green, right? And then it shows you gives you different output data on the other side. So let's say let's reset that. I'm just drawing a kind of random territory here. This is better if you can do it on an iPad. That's a little bit more fun. But let's say we simply look at this kind of condition and we say, well, this is actually typical for an American. This is a very typical American relationship between countryside and city and density. So first of all, we can see that this is very low density, and you can see that these are very large holdings. These are about 80 hectares, and they're mostly doing wheat or maize. So most of the population is quite concentrated. Let's say we compare that with Japan. You can see that the scale of the landscape changes. These are much tinier kind of holdings by comparison. I don't know if I can't get Indonesia here, but let's do China. And this is why the Chinese government is so worried, because the fragmentation of population is breaking up both the population but also the fertile areas. So if you take this as a pure centralized planning problem, their solution is to bring the populations together. And then Ting is working on this area, and of course that's causing massive problems. It's very easy in theory to do that, but actually to do it for real is very, very complicated. So there's all kinds of resistance and all kinds of difficulties with this top-down kind of planning with these master dimensions in mind. There's other things we can do. Let's say we go to expert mode, and we can change the land holding sizes. So this is what the Chinese government would like to do, is to make larger land holdings, which makes rice more easily mechanized. This is the mechanization level. We can push that up. And as I push that up, the population goes down, because we know there's a rough relationship. The more mechanized the countryside, the less people there are, because there's no work. They have to go to the city, or they have to find another way to make money. So there's a very simple relationships that you can estimate between these different parameters. There's also an interesting thing, if you get higher value crops, let's say you change rice and make it fruit, trees, or vegetables, you're already starting to improve the rural economy. And also you're allowing people to stay in the countryside and to thicken, to urbanize in situ rather than to come to Jakarta or Surabaya, which is also sort of a problem. And then finally, we can also start to think about what happens if you put a road system through here. So it changes the morphology of the landscape as well. So these are very simple things. You can take land area, crop yield, labor, mechanization, and calorie production, and you can put that all together, and there's a way in which you can study those parameters, and you're already probably in the right ballpark in terms of policy and planning regions, planning parameters. What I can't show you is down here is the Indonesia case because of just the screen reference. But Indonesia looks a little bit more like this, except in Indonesia, when you put a road, all the population density comes to the road, and you know that because that's a very important economic corridor. That's a very typical pattern in Indonesia. Okay, so that's the kind of experiment that we did along the way, and then we're all leading towards this ur-scape moment, right? So I'll just press on. Oh yeah, I'll just show you this because this is David, who is the designer of ur-scape, and he works with Serene, who you can meet in a moment. But this is another way of using that same model, but here we're using a kind of sort of a simpler kind of interface. And it was designed to be able to play with it so different people could start to think about these parameters in creative ways. All of this technology is very simple, it's off the shelf. It's quite amazing what David managed to do with just going to the computer shop and bringing a couple of sensors and a data projector. But here you see a little bit more dynamic how the different parameters are starting to interact. Okay, now let's come to ur-scape. ur-scape then came from that theoretical background and some of those methodological problems. Then we had an invitation from the Asian Development Bank and the ministry here in Indonesia of Agraria Tanaman. And they said we want to start to think about this question in Indonesia. So we're very pleased because out of the theoretical background for the last 20 years is now becoming policy. Indonesia has to think about what to do about the countryside because of this kind of food security question and so on. So then they gave us a little bit of seed money. They saw what we were doing with ur-scape and said, could you develop that in a slightly more policy framework? And the first case they gave us was the metropolitan region around Palembang. Now Palembang is very complicated, it's very hard to kind of move around that area, but also the data, the first thing we did was try and understand what's currently available. So we went to every single one of the kabupatens in that area, and every single place had a completely different way of thinking about data. So this is in one place, and I love this because it's pointing to the spot, and it's a very lively discussion. And then we went to 5 or 4 other different kabupatens, and you can see every time, sometimes it's just a historical map, printed map, which has been worked on. Sometimes it's a very beautiful GIS sort of system. Sometimes the planning authority was just using Google Earth on a smartphone, which is also very effective, actually. And then other times they had a huge amount of funding from a Korean funding agency and did something very, very sophisticated. But for us, this felt a little bit like having a Ferrari on a company road. You know, it was just wrong technology, wrong system. And then sometimes they just took us to the map on the wall. So there was a completely different kind of data scape. So we had to kind of assemble our own data. So we were tracking through all of this region. And here we're working with the satellite. So we're using the best available satellite that we could afford. And then started to use kind of social interactions to thicken that landscape. And then we combined it with UN data, FAO data, much more global data, which is also available and free. And then this one, I won't spend long on this, but this gives you just a bit of background of how this is all the SEL background. So we started by assembling all of these different sorts of maps, the different available maps, and you can see they're incredibly varied. So there's no single data set, single reliable data set. Our approach is to use everything that's available and cross-reference it. So that's one day in the future there will be one single beautiful data set, but it's never. In the meantime, there's a lot of work to do. So let's just use what's available. So we interacted with our colleagues. I'm just going to show you. There's lots of us traveling because traveling was a big part of it. This is mostly in the Kepulauan and Riau area. So these are colleagues doing interviews on local economic outputs from those villages to connect with the BPS data and to connect with the satellite data. this is where the coding begins. These are early versions. We're working on Batam because it's very close to Singapore, and we could be directly involved with Bapeda and doing interviews on a regular basis, starting to think about macro, micro at the same time. And you can see, we can start to then, the format you can start to see is what we already used before. Different data sets here, mostly public. There are different tools over here. Later they move down here. And then we can start to study them in our lab. I mean, this is all very beautiful, but you don't need the lab. You just need a laptop. We're very pleased about that. And then over here, you can start to see that you can start to make planning propositions. This is not detailed urban design. I was talking about Heru earlier. This is really about just the macro parameters. This is not refined enough. Yeah, that's not happening. Okay, and then this is a screen grab again of West Java, this the most recent version of ur-scape. And what you can see is that it's combining rice data and population density data. And Rosita will show you that live in a minute. But you can see there's nobody growing rice in the middle of Jakarta or Bandung. But there's a huge population density and rice correlation all through that region. So this is a really interesting phenomenon, and I think it's very exciting because I think urban designers and planners have to start thinking about that because the government is already wanting us to think about that. And if it's relevant here, it's relevant in Vietnam, and in Dhaka, and in Bangladesh, and in Bengal, and so on. So this is not just a Java question or a Bandung question. This is the whole of that monsoon area. I probably also didn't say that inside that monsoon area is half the world's population. So this is a really serious, very serious large-scale issue. Okay, I think Rosita will talk to you a bit more. This is the aims of the software itself. It's open source. Please look at it and play with it and let us know what you think. This is just a summary of what we did. So I started by saying, why should we as urbanists start thinking about maize and rice and agriculture? And I'm trying to say that that's important because of this gap between the rural and the urban. The rural and the urban gap is not a gap in Asia, especially in Java where they're not overlapping. So for that, we have some really nice evidence already. And there's some theoretical background that we know about from geography and sociology. But we need to be very inventive around the different methodologies that we use. So urbanists have to be thinking about remote sensing data and interacting with that data. There was some other versions here which I didn't show you, but I'm happy to send you. And then we did our first experiments with Java. We were using dynamic attitudes to that data. So we dissolved the political boundary and started to think about it as a dynamic condition. And then we started making, this is the first sketch model where we thought about the relationship between density and agriculture, mechanization, and so on. And then this is where we had the ADD and then how they had support. And then this is where we are now. And I think I'll pause here while Rosita sets up, and maybe if you have a couple of questions, we can then talk again at the end. Okay, thank you. So do you have any questions about this? And then Rosita will take you through some live scenarios. No questions at all, sorry.
The pre-ur-scape sketch model you were showing,
Yeah.
is that based on some sort of econometric modeling? When you change one parameter and you see the impacts on these outputs, where do those...
The relationship...
mathematical model?
No, it's all empirical. It's all empirical. So we're modeling the existing conditions in each case. So in America, the relationships are quite observable. You can observe the scale of a farm and the scale of the population density on that farm. And then there are ways, from the FAO, for example, you can then, they can give you the mechanization rate. So
So it's an interpolation between existing data.
It's correlations of existing data. And there's a good point to raise. We're not making models, we're not predictive. And that's very important because I think people move to prediction too quickly. My colleagues are all modeling predictive people, but they have great data. They can make very profound, and if they don't have the data, they find it, and they find it, and they find it. And such high resolution data, they can make quite good, even then the predictions I don't think are very accurate. So what we do is say, let's just assemble what we already have, and let's do correlation. And the correlation then makes you have to then think, makes us all think. What does it mean if high population densities and rice are correlated? What does that mean? We could make a model about that in the future, but that's expensive and complicated. But we can already start to make discussions. We can already start to think as planners and urban designers. So that's what our aim, as we keep saying, our aim is to improve the quality of the discussion. We're not trying to make an automatic planning machine, because I actually don't think that exists, even though I have many colleagues who say it does and should. But we have a kind of we're still designers in that sense. So yes, we're interested in correlation. We observe and we gather empirically the best possible data that we can find. Other questions? Yeah.
Just now I saw your program is, I saw that your exampling of the urbanization program is based on the configuration of USA, Japan, and China. Are you planning to add more existing cities in your template for your urbanization simulation? Like, because I think for our country, Indonesia, I think it's a lot different from each of those three countries.
Yes, I couldn't show you. Indonesia is the fourth one,
No.
but it was cut off by the screen.
Oh.
It's because this tool, you can't scale the tool. I can show you later.
Oh, but are you going to add a lot more different cities?
Yes. Rosita will show you. This is it's global, and we'll show you the current. In a minute, you'll see some examples. Maybe you can just do a quick tour in a minute. Any other questions on the theory or the method? Okay, if not, let's... Yeah.
When you mentioned that when we have a new road like on Indonesia,
Yeah.
and then you said that the population will go
Yeah.
along the road, how do we come to that conclusion?
Yes, it's the same question.
Yeah.
It's
So
just
it's
it's
based-
just observation. We're not modeling. So behind each of these is real data. So let me give an example. So that data was found in a time series in a region on the east of Jakarta. So it's actual comes from a particular spot. We'll show you again some other data sets that we use in one city and apply to another. In a minute, Rosita will show you some transport data, network data from Semarang that we've applied in Palembang. Now, no proper scientist would do that, but it's our provocation. We say to Palembang, we're using Semarang data, you've got to find your own data. And we can show you how to do it, it's very easy. It's what I think architects and urban designers do. Observe, look, measure, see what's there, and then you make a kind of rule of thumb. It's a kind of it's not highly theoretical, you kind of make a kind of rule of thumb, and then you can discuss. So I think that's different to a kind of much more theoretical, rational. Okay, so we hear from Rosita, and then we can also have some more discussion here.
Bisa kedengaran kalau saya berpakai mic, bisa ya. Jadi ini tampilan ur-scape yang versi terbaru. Kalau yang belum pernah lihat, jadi yang saya akan jelaskan sedikit, ya agak sedikit yang jelas. Yang di sebelah kiri ini adalah semua list data layers dari berbagai sumber, apakah itu dari kota atau open source dan sebagainya. Lalu di bawah sini ini adalah layer-layer background. Jadi saat ini ada layer basic background, bisa juga satellite image di sini. Dan ada di bawah situ ada beberapa juga tool, contours tool, planning, reachability, timeline, word count, municipal budget, dan export. Jadi pada dasarnya contours tool itu berfungsi untuk mengiris beberapa layer data untuk menghasilkan tergantung parameter yang akan digunakan supaya kita tahu misalnya tadi masalah rice production dengan population density dengan menggunakan contours. Lalu ada planning itu untuk mendemonstrasikan atau mentes mengevaluasi beberapa planning skenario yang mungkin. Lalu juga yang ketiga itu ada reachability, itu berkaitan dengan tadi akses jalan dan aksesibilitas terhadap fasilitas publik dan sebagainya. Lalu ada timeline, karena itu berfungsi berkenaan dengan time series. Kalau kita menjaga time series, kalau kita mau lihat yang ke word cloud dan municipal budget itu adalah dua fungsi yang khusus di develop untuk Kota Bandung. Yang word cloud itu berhubungan dengan bagaimana kita memasukkan data kualitatif, misalnya dari hasil survei ke dalam ur-scape, ke dalam softwarenya. Lalu juga municipal budget itu adalah bagaimana kita bisa membagi misalnya APBD daerah sesuai dengan parameter yang akan digunakan, apakah itu akses air dan sebagainya. Lalu ekspor adalah fungsi bagaimana kita bisa mengekspor hasil analisa dalam bentuk JPEG atau CSV yang bisa digunakan berikut selanjutnya. Lalu di sebelah kanan itu adalah info tentang ur-scape mengenai versi ini. Di bawahnya yang penting adalah site browser. Itu di sini kami ada 3 ditampilkan. Ada level global, world, Bandung dan Palembang. Tentu saja ini bisa ditambahkan sesuai dengan kota-kota yang akan digunakan. Jauhnya dari izin dan kredit. Saya akan mendemonstrasikan beberapa skenario. Tadi Prof. Siman sudah sempat berbicara tentang masalah risk production dan population density. Tadi ada image-nya, lalu bagaimana kita coba lihat secara live. Jadi ini adalah Pulau Jawa. Ini data rise. Di sini ada slider yang bisa digeser. Jadi kita tahu daerah mana yang mempunyai hasil produksi rice yield yang lebih tinggi. Lalu kita coba kaitkan dengan data population density. Juga ada slider, jadi kita tahu daerah mana yang lebih tinggi. Lalu dengan menggunakan contour tool, kita bisa lihat itu adalah area-area yang mempunyai population density dan rice yield tinggi. Bagaimana dua data ini overlap? Itu pada data skala global. Lalu skenario berikut yang akan saya jabarkan berkaitan dengan kerjasama kami dengan Kota Bandung. Pertama dengan Kota Palembang dulu. Saya akan masuk Kota Palembang. Jadi salah satu prioritas perencanaan di Kota Palembang yang kami dapatkan adalah berkenaan dengan kerentanan terhadap banjir. Jadi di sini ada data tentang banjir yang didapatkan dari pemerintah Kota Metropolitan Palembang. Sama di situ ada fungsi slider di mana kita bisa melihat di sebelah kiri itu ada angka 0 dan di sebelah kanan ada angka yang lebih tinggi. Jadi semakin ke kanan menunjukkan bahwa ini adalah area-area yang mempunyai kerentanan banjir lebih tinggi dibandingkan area lainnya. Lalu pertanyaannya adalah bagaimana kita merelasikan ini dengan perumahan penduduk untuk tahu perumahan mana yang mempunyai kerentanan banjir lebih tinggi. Jadi di sini ada pola ruang metropolitan. Saya akan pilih di sini beberapa fungsi. Saya akan pilihkan misalnya settlement dan activity untuk perumahan. Saya nyalakan fungsi ini. Lalu dengan menggunakan fungsi yang sama, contour tool, saya akan klik di sini. Jadi ini langsung menghasilkan ini adalah area pemukiman dan aktivitas yang mempunyai kerentanan banjir yang lebih tinggi. Juga kalau misalnya kita mau coba lihat mana yang lebih tinggi, bisa langsung di slide. Ketika kita menggeser, kita akan terlihat area-area mana yang mempunyai kerentanan sangat tinggi, misalnya dengan sesuai dengan parameter yang akan ditetapkan sebagai indikator. Itu adalah salah satu skenario. Lalu saya akan bergerak juga mengenai sekarang tentang aksesibilitas. Sama di Metropolitan Palembang. Salah satu contohnya misalnya rumah sakit atau pelayanan kesehatan lainnya. Di sini ada data-data tentang rumah sakit. Di sini kami ada data rumah sakit umum dan spesialis. Misalnya saya hanya nyalakan satu saja, di rumah sakit umum. Menggunakan fungsi yang ketiga di situ, reachability. Ini adalah rumah sakit umum. Lalu dengan menggunakan reachability di sini ada beberapa fungsi, misalnya ada mobil, motor, berjalan kaki, dan ini bisa biasanya bisa di customize sesuai dengan kebutuhan, apakah tambahan lainnya, sepeda dan sebagainya. Lalu ada travel time, di mana dia bisa digeser juga sesuai dengan waktu yang akan ditetapkan sebagai minimum good access atau akses yang baik terhadap akses rumah sakit misalnya. Misalnya saya di sini tetapkan 30 menit dengan berkendaraan sebagai batas maksimum bahwa itu adalah akses yang baik dari rumah sakit. Dengan menggunakan ini, kita dapat langsung menggambarkan ini adalah area-area tangkapan yang mempunyai akses baik terhadap rumah sakit umum di Metropolitan Palembang. Lalu pertanyaannya lagi adalah bagaimana kita kaitkan dengan fungsi misalnya perumahan. dan aktivitas lainnya. Saya akan nyalakan settlement di sini. Saya matikan dulu di sini. Lalu dengan menggabungkan dengan fungsi yang pertama, contour tool, kita langsung bisa mendapatkan ini adalah area-area pemukiman yang punya akses baik terhadap rumah sakit. Artinya dalam waktu 30 menit bisa mencapai rumah sakit itu, dan dengan demikian kita bisa lihat area-area di luar ini adalah area yang mungkin membutuhkan penempatan rumah sakit di depan. Skenario berikutnya saya akan pindah ke Kota Bandung tentang bagaimana menggabungkan data kualitatif survei. Jadi di Bandung itu ada IMUS Medbank. Kalau yang tahu bagaimana kita bisa mengkolek survei dari tingkat RW. Jadi ini ada data IMUS Medbank. Saya menggunakan word cloud. Saya akan nyalakan IMUS Medbank. Di sini bisa dilihat kata yang terbold, yang lebih jelas itu menyatakan itu adalah aspirasi masyarakat yang terbesar disampaikan melalui IMUS Medbank. Begitu kita juga bisa zoom in ke dalam skala yang lebih kecil, apakah pada skala kota sama dengan skala misalnya lebih kecil dan skala lingkungan. Begitu kita zoom in, kita bisa mulai melihat berbagai macam aspirasi yang masyarakat sampaikan melalui survei. Dengan begini kita bisa melihat juga prioritas perencanaan mana yang harus difokuskan secara lebih khusus untuk setiap area-area ini. Juga untuk Kota Bandung. Yang berikutnya adalah tentang municipal budgeting. Misalnya saat ini berkaitan dengan bagaimana pembagian anggaran daerah sesuai dengan parameter atau bobot masing-masing. Misalnya saya menggunakan akses ke sumber air sebagai indikator pertama. Ini adalah distribusi akses sumber air di Kota Bandung. Juga ada slider di mana kita bisa melihat mana yang mempunyai akses lebih banyak terhadap air di Kota Bandung. Saya akan menggunakan municipal budget di sini. Langsung di sebelah kanan itu adalah daftar nama kelurahan dan pembagian APBD-nya sesuai dengan jumlah akses terhadap sumber atau presentasi akses terhadap sumber air. Dan sebelah kanan itu ada presentasi APBD yang dibagikan. Pertanyaannya adalah bagaimana kalau kita punya beberapa indikator, bukan cuma akses, misalnya kita tambahkan juga jumlah kepala keluarga miskin. Ya, begitu kita tambahkan satu layer berikutnya dia akan berubah. Juga misalnya kita punya data misalnya kepadatan penduduk, dan dia juga berubah. Satu hal lagi yang bisa kita lakukan adalah karena setiap indikator itu mungkin punya bobot yang berbeda-beda, tidak semuanya 100%. Kita bisa slide juga, misalnya saya akan kurangi akses terhadap air, bobot terhadap air. Dan sebagaimana saya menggeser bar itu, dia akan berubah secara otomatis. Kelurahan mana yang membutuhkan akses atau misalnya persentase APBD lebih tinggi dibandingkan area-area lainnya. Ini adalah skenario terakhir yang kita akan tampilkan berkaitan dengan planning. Itu adalah satu tool baru yang kami juga baru kembangkan. Saya akan close sebentar ya. Jadi ini tampilan back-end-nya ur-scape sebenarnya. Jadi tadi kan kita mulai dari skala global, skala kota ya. Lalu bagaimana kalau kita mau fokus yang lebih kecil, skala misalnya skala lingkungan, untuk melihat apa yang bisa kita skenario perencanaan apa yang bisa kita evaluasi, kita bisa coba latihkan atau bisa kita coba tes. Nah di Kota Palembang itu saat ini ada beberapa kawasan khusus yang dialokasikan pada dalam RPJR 2030. Salah satunya yang penting adalah tentang agropolitan, kawasan agropolitan. Saya akan nyalakan kawasan agropolitan di sini. Itu ada di lokasi di HCT-nya Kota Palembang. Lalu tentu saja untuk pengembangan kawasan kota agropolitan yang pertama kita lihat adalah kemungkinan menaikkan populasi density, tapi tidak juga merubah produksi rice, misalnya produksi agriculture. Jadi di sini saya akan tambahkan dengan ada pola ruang kota yang didapatkan dari kota. Ada beberapa perumahan di sini, perubahan padat, rendah, dan sedang. Saya akan nyalakan perubahan kepadatan rendah pada perdagangan jasa. Lalu saya akan crop untuk mendapatkan ini adalah dua area dalam agropolitan Palembang yang berfungsi sebagai perumahan rendah, berpadan rendah, dan juga perdagangan dan jasa. Saya akan simpan di sini. Jadi kita punya fokus dua area di mana kita bisa melihat untuk mengevaluasi atau mengetes skenario perencanaan. Lalu layer yang bisa digunakan sebagai indikator di mana kita bisa mencoba memasukkan skenario perencanaan adalah green cover, karena berhubungan juga dengan ketutupan lahan hijau. Jadi bisa dilihat di sini area-area yang tidak hijau adalah area yang mungkin bisa dipakai untuk pengembangan misalnya perumahan baru atau development area pemukiman baru. Lalu ada di dalam tools ini ada yang namanya planning tool. Jadi salah satu fungsi planning tool adalah kita juga bisa memasukkan target, bagaimana target populasi yang mau dicapai melalui area ini. Misalnya saya akan tetapkan di sini 2000. Yang mungkin crop production-nya akan dimasukkan misalnya 5.000. Oke, saya akan simulasikan di titik ini. Di sini ada beberapa tipologi elemen atau bangunan yang sudah dimasukkan, dan ini juga bisa dimodifikasi. Ada ruko, rumah tinggal, apartemen tingkat rendah, tingkat tinggi, rumah tambah, ruang terbuka, panen bernilai rendah, panen bernilai tinggi, pedestrian values well, dan tanah kosong. Dan di sebelah kanan ini akan menampilkan informasi dari planning atau tipologi yang akan dimasukkan ke dalam area ini. Misalnya saya akan tambahkan juga di sini plot rasio nanti. Misalnya di sini saya akan masukkan panen bernilai tinggi sepanjang jalan ini. Jadi ketika kita memasukkan sel-sel dalam ini, bisa dilihat bagaimana graf itu langsung muncul berapa kenaikan crops-nya, dan juga di sebelah kanan bisa dilihat berapa kenaikannya. Apakah kita sudah cukup banyak memasukkan skenario-nya? Misalnya kita mulai memasukkan tipologi bangunan ruko. Misalnya juga kita masukkan rumah tambah. Rumah tambah adalah salah satu tipologi bangunan yang dikembangkan oleh FCL. Lalu misalnya bagaimana kita juga memasukkan ruang terbuka. Saya akan tambahkan elemen-elemen lainnya. Kita lihat menambah juga di sini. Ada ruko lagi di sini. Jadi fungsi tool ini adalah bagaimana kita bisa melihat trade-off dari fungsi setiap tipologi bangunan yang akan diintroduce. Apakah kita memasukkan ruko, apa yang akan kita dapat. Kalau kita masukkan panen bernilai tinggi, apa yang kita bisa dapat. Jadi dari kanan bisa ditampilkan apakah kita sudah mencapai target yang kita tentukan di awal. Misalnya di sini kita hanya mencapai 17% populasi dari target yang kita set di awal. Dan di sini kita bisa mulai terus bereksperimen, skenario perencanaan apa yang bisa dikembangkan berikutnya. Jadi itu beberapa skenario yang kita lakukan. Ada pertanyaan?
Silakan pakai bahasa Indonesia.
Ini kan semua apa yang dalam kita aplikasi kan mendapat case, tapi kan indikatornya bisa sama. Apakah ada tesnya atau sama? ini input datanya itu SHP atau ya, jadi ini kan dalam memprediksikan sesuatu berbagai case itu indikatornya kan bisa sangat banyak gitu. Nah itu ada batasan indikatornya nggak sampai berapa banyak. Terus input datanya ini basicnya pakai apa SHP atau
Yang pertama sih kita bisa langsung ke beberapa layer. Pesawat ini kami belum pernah ngetes sampai banyak banget, tapi sejauh ini setiap kami menggunakan banyak layer, dia masih bisa dipakai. Misalnya 5 kami juga pernah coba 5 indikator masih bisa. Atau mungkin lebih kita bisa tes sama-sama menyalakan semua layernya. Untuk masalah data file, ini kan geospasial, jadi tentu saja basicnya ada SHP, tapi ada proses yang perlu dilakukan memindahkan SHP dalam bentuk CSV yang bisa dibaca oleh ini. Jadi sebenarnya ur-scape-nya sendiri ini membaca hanya file CSV. Ya.
Ada lagi?
Ya. Ya ini kan kalau mau kami perlu membangun data, problemnya membangun data, info. Siapa yang bertanggung jawab? Apakah ini semua orang bisa mengembangkan data kemudian dari center cloud-nya sehingga semua bisa berkembang seperti itu menggunakan data itu? Apakah ini individual by cases di collect data atau fokus? Bagaimana strateginya? Apakah idealnya ada database yang centralized atau memang by case saja nanti? Bagaimana?
Saat ini kalau ketika kami ke kota-kota itu karena memang data kota itu confidential, biasanya mereka tidak mau share dengan mungkin ada penerbangan yang tidak bisa di-share dengan publik. Jadi biasanya itu lebih desktop, jadi nggak di-share di cloud. Tapi ada kemungkinan untuk bisa di-share melalui cloud, dan nanti berarti datanya harus ditaruh di cloud, jadi bisa diakses. Tapi berarti karena sebenarnya kalau saya boleh tampilkan backend-nya itu seperti ini. Jadi selama ini bisa diakses dalam cloud, berarti bisa diakses dari mana saja.
Jadi ada senternya ya.
Tapi kalau dari software-nya sendiri sih, itu tergantung data management sistemnya. Misalnya kalau satu kota dia mau pakai dari misalnya beberapa SKPD yang hanya mau memakai satu data, selama kotanya mau men-sharekan atau misalnya wali data pusatnya mau men-sharekan dengan banyak SKPD, bisa dilakukan dengan arti data ini semua filenya harus ditaruh di dalam cloud-nya mereka.
Di SDL ada satu yang kami buat dan dipelihara supaya demonstrasi. Jadi itu kan datanya terjamin dari sumber-sumber umum. Tapi di setiap kota atau ini masalah kelembagaan ya. Jadi kalau ATR mau punya silakan, tapi in-house saja atau mereka datanya sendiri. Kalau ada yang mau di-share ya silakan. Tapi modelnya decentralized, jadi bukan satu. Tapi yang di SCL sudah ada ur-systems is a publicly available, pakai data umum dari UN, FAO.
Karena ini sangat menarik, sangat bermanfaat untuk masyarakat sendiri. Nah, tinggal policy ya, mana informasi yang boleh publik harusnya menjadi hak masyarakat diperjuangkan, dia harus dapat informasi mengenai rencana pembangunan misalnya atau apa gitu ya, sehingga semua bisa membuat planning dengan
itu sangat penting sekarang. Itu polisinya ATR atau mereka yang harus membimbing kami untuk bagaimana caranya mengembangkan arahnya.
Kalau belajar dari negara yang sudah maju, bisa diusulkan kepada government minimum information supaya masyarakat tumbuh, kan ekonominya kan cepat sekali nih mau berkembang, kalau enggak nggak bisa bersaing gitu. Bagaimana yang bisa di-share di masyarakat, sehingga malah dia harus menyediakan data itu di masyarakat. Kalau enggak, kita mencari-cari pemerintahnya suka nggak suka gitu. Itu ada teori background yang memang ini kalau dilepas terus yang berkembang, mungkin ada lebih bagus.
Ada lagi pertanyaan?
Si ur-scape ini dia ketika kan tadi kita bisa menentukan berbagai macam skenario. Nah, ketika kita menentukan berbagai skenario itu dia skenario untuk environment impact seperti dari bencana ataupun vegetasinya dia menjadi pertimbangan ya untuk diaplikasi. Oh, sorry. Jadi kan kalau ur-scape ini dia itu kita bisa membuat berbagai macam skenario. Nah, apakah skenario yang dibuat ini dia udah dikorelasikan dengan berbagai macam tadi ada banjir sih, tapi berbagai macam bencana alam yang lain dan juga vegetasi existing di situ, sehingga kan mungkin aja ketika kita skenario di sini ternyata tempat itu baik, tapi ternyata di situ ada potensi bencana yang baru, itu jadi pertimbangan gitu.
Tentu saja jadi pertimbangan selama datanya ada. Jadi itu balik lagi ke masalah datanya ada apa tidak, kualitas datanya bagus apa tidak. Misalnya kita bicara tentang kota, tapi data yang ada skalanya nasional. Jadi agak sulit, tapi mungkin bisa dipakai. Tapi kita perlu melihat lagi lebih detail apakah data itu sudah cukup untuk mengevaluasi misalnya tadi banjir skalanya kota, misalnya gempa skalanya nasional. Itu perlu pertimbangan apakah kita tentu saja kita bukan berarti tidak bisa memakai datanya, kita bisa pakai, tapi itu balik lagi berarti kita memerlukan berikutnya adalah pengumpulan data pada level kota.
Kami sering ceritakan bahwa ini seperti apa yang mencerminkan data yang ada. Cerminnya cukup tajam, tapi masih cermin, bukan alat prediksi dan lainnya. Pokoknya gini, kalau ada datanya silahkan masuk, bisa kami pikirkan. Kalau nggak datanya nggak, tolong hubungkan dengan mahasiswa atau cari datanya.
Iya, kita dapat question.
Kalau dilihat dari awal kita kan ini kan berbasis didapat dari data-data yang dari kota-kota di Indonesia. Sedangkan kalau dilihat Indonesia itu kan tiap kota itu nggak semuanya memiliki data yang dibutuhkan gitu. Jadi kita harus memikirkan kemungkinan terburuk kan sebenarnya dari program ini gitu, hasil ur-scape ini. Nah, apakah ada kemungkinan ke depannya kalau emang data-data itu tidak mengalami peningkatan gitu, terus untuk digunakannya itu seperti apa? Apakah akan menjadi sebuah hambatan gitu untuk ur-scape ini? Karena kan data-data kan sebenarnya semua itu bergantung pada data-data yang ada di tiap kota itu. Sedangkan kalau kita lihat Indonesia gitu kan, betapa sulitnya gitu kita untuk mendapatkan data, mengolah data kan gitu.
Sebenarnya mungkin kalau hambatan menggunakan ur-scape-nya tidak, itu mungkin lebih menghambat ke arah perencanaannya kalau datanya tidak ada, karena ur-scape-nya sendiri dengan data yang ada di tahun-tahun sebelumnya bisa dimasukkan gitu kan. Cuman itu balik lagi ke pertanyaan ke masalah pengumpulan data ya. Apakah dengan begitu kan seperti Prof bilang itu adalah cermin untuk kita juga melihat apakah kita perlu memperbaiki sistem pengumpulan data kita.
Ini dibutuhkan juga kayak sosialisasi yang lebih dalam gitu untuk setiap kota-kota di apakah. Berarti dari yang ur-scape ini juga udah mencoba gitu untuk mensosialisasi.
Ya, jadi sebenarnya kita tuh sudah kemarin kita sudah berdiri di Kota Bandung. Kebetulan sebenarnya kemarin kita ada training. Nanti saya akan dengan Bandung. Lalu Palembang sedang berjalan, Makassar dan Semarang. Ada 4 kota yang sedang sebenarnya menjadi pilot studi percampuran di Indonesia. Jadi kalau saya tampilkan sedikit kemarin itu kita memberikan pelatihan kepada Kota Bandung, ada Kota Bandung dan ada 6 SKPD yang datang. Bagaimana menggunakan ur-scape di tiap dinas masing-masing, dan juga ada kementerian yang datang. Dan cukup menarik dari image ini, sebenarnya ini bukan kami yang membuat. Jadi ada satu bapak dari dinas kesehatan, setelah kami selesai training, dia balik ke rumah dan dia langsung masukkan data dengan demam berdarah. Jadi kalau bisa dilihat, ini yang pertama, ini adalah data tentang kesebaran demam berdarah di Kota Bandung. Kami tidak punya datanya, sebenarnya datanya dinas. Lalu dia juga coba dengan data kepadatan penduduk. Jadi di sini dia hanya baru melahirkan datanya, tapi begitu dia menggunakan fungsi kontur tadi dia bisa melihat mana daerah padat penduduk dan juga punya kasus persentase atau kerentanan dari demam berdarah. Jadi di situ kita bisa melihat bagaimana kota-kota itu bisa mulai menangkap fungsinya ur-scape untuk bisa memvisualisasi data. Problemnya juga karena seperti kita tahu mungkin dinas kesehatan tidak punya pengetahuan tentang, mungkin tidak punya ahli misalnya tentang data spasial, atau mungkin tidak semua, karena dalam dinas ini tidak semuanya orang punya background spasial. dengan menggunakan tools ini, setiap orang bisa mempunyai bahasa yang sama untuk melihat problemnya kota atau potensi kota yang bisa dikembangkan.
Ini contohnya bagus sekali karena kami senang sekali pertama kali ada rekan dari kota yang cari datanya sendiri, uploadnya sendiri tanpa ya ada instruksi sedikit-sedikit tapi mandiri. Jadi kami senang sekali. Ini juga bagus sekali. Contohnya ini kan ada apa? Dengue ya, demam berdarah ya. Tapi nggak mungkin kan nyamuk nggak mau membatasi itu. Nggak mungkin kalau nyamuk dibataskan. Kenapa ada? Ini kan bolong, datanya bolong. Ini persis contohnya bisa kami tampilkan. Ini datanya karena nggak ada. Langsung cari aja untuk dilengkapi. Jadi bisa ceritanya bisa lebih lama, bisa lebih lengkap. Tapi bukan tanggung jawab kami atau kita untuk melengkapi datanya.
Berarti
Didorong gitu.
ini sebuah fasilitas gitu kan untuk kita mendapatkan data-data.
Ini sebagai fungsi persis sebagai cermin. Kalau ada bolong, carikan data supaya bisa kami semuanya bisa gotong royong dalam proyek-proyek yang lebih menantang seperti yang lagi.
Boleh saya tambahkan? Saya sehari settingnya pasti evaluasi dan juga masalah data di Indonesia sebenarnya lumayan menjanjikan. Karena kan di tahun terakhir ini ada policy khusus dari kantor presiden yang disebut data policy itu kan. Jadi semua policy yang badan-badan di Indonesia itu harus mengacu pada satu data tematik. Nah bagusnya kan sebelumnya itu data dunia apa segala macam itu mereka punya ketakutan dasar yang berbeda-beda. Jadi begitu dilayarkan itu wah nggak jelas, nggak konsisten. Nah bagusnya dengan adanya polisi itu di-push secara langsung dan secara aktif ke semua balai-balai dan kota-kota. Jadi mereka harus menjalankan ini implementasinya. Dan salah satu polisinya itu juga berkaitan dengan skala data, format data itu juga diatur. Dan mudah-mudahan kedepannya itu bisa lebih baik lagi implementasinya. Kalau di sana sudah kejadian akan lebih mudah untuk kekuatan dan balai-balai itu untuk memakai tool seperti ini.
Okay. So I want to say thank you. I want to just maybe 2 or 3 underline. This is our team. Although we have these beautiful screens, our team is quite small in Singapore, and this is designed as open source. So this is an invitation to you to download the software and start to play with it. At the moment, it's an open field, but please stay in touch with us, and then we can also stay in touch with. We come back to the institutional question before: is the ministry or Bapeda, how is it handled at a formal level? But we also will propose to develop the planning tool, so it starts to become more like an urban design tool. So we'll also keep you in touch with that. But if you are good at programming or you are good at Unity game engine, then please start to develop it yourself and let us know. Next year we will have a conference in Singapore. So if you have a really good new tool, we have 5 tools. If you invent your own tool, come and present it at the conference, and it'll be like an event where we can start to really think about the distribution of the responsibility to develop the tool, to gather the data, and make the scenarios which are relevant to your neighborhood or maybe the project that you're doing here. So stay in touch with us. This is the website. Thank you.
Okay, so with this, we thank Professor Stephen Cairns and the team, all the guests for presenting this tool, and hope we can collaborate in the future. Thank you.
Thanks again.